Hey everyone, welcome back for another deep dive. Today we're going to be digging into some really fascinating AI research, specifically a new large language model called Solar 10.7b,
And for those who might not have LLMs on speed dial yet,
which is fair.
it's basically a supercomputer brain that's learned to understand and generate human-like text by crunching through tons of data.
Yeah, like imagine having that kind of cutting edge AI, not just stuck in some tech giant's lab, but actually accessible? And that's a big part of what makes Solar 10.7b so interesting. It's open source. It's like someone decided to share the recipe for a game-changing invention with the whole world.
And that's where that Apache 2.0 license they keep mentioning comes in, right? It basically means
Okay.
anyone can use Solar 10.7b even for commercial stuff without any legal headaches.
So no more AI exclusivity club then.
Exactly. And this is huge because it levels the playing field for smaller companies, researchers, even just someone tinkering in their basement. It's all about making this technology more democratic.
Right, because up until recently, the name of the game in AI has been bigger is better. The more massive the model, the more powerful it is. Which makes sense to a point, but those mega models require a crazy amount of computing power and resources. Not exactly accessible for everyone, is it?
Exactly. It creates a very real barrier to entry. And this is where Solar 10.7b comes in with this really cool approach they call depth upscaling, or DUS.
And DOS, just to clarify, isn't about making the model physically bigger.
No, it's more like, imagine building a skyscraper. Instead of just expanding the base, which takes more land and materials, you strategically add layers, maximizing the efficiency of the space you've got. DUS is about strategically building on existing knowledge to create something new and impressive.
So it's like they're finding ways to recycle existing AI knowledge, which is amazing. But the question is, can it actually perform? And the answer seems to be a resounding yes.
Right. What's so fascinating is that even though Solar 10.7b is significantly smaller than some of the giants out there, it performs incredibly well, especially when you look at things like reasoning, math, and general knowledge.
And speaking of putting it to the test, they ran Solar through a bunch of benchmarks, which are basically standardized tests for AI. And one of those benchmarks was GSM 8K, which is all about mathematical reasoning, not exactly a walk in the park.
And this is where I was blown away. Solar's scores on GSM-8K are shockingly good, especially when you remember its size. It really shows you don't need to build a massive model to get incredible accuracy and problem-solving abilities.
And when they say high levels, they really mean it. Solar 10.7b is going toe-to-toe with models many times its size on these benchmarks, and in some cases even beating them. So we're potentially talking about a paradigm shift here in how we think about developing AI.
Absolutely. Solar is challenging those deep-seated beliefs about size and performance in AI, and in doing so, it's opening up all these possibilities for what we can achieve with more efficient, accessible models. However, that doesn't mean it magically learns everything it needs to know just by existing.
It's like that old saying, you can't teach an old dog new tricks, but luckily AI doesn't really have that issue, do they?
Right. It's not really about teaching tricks with LLMs like Solar. It's more about guiding their learning process. I guess making sure they can use all that knowledge in a way that makes sense.
So how do you train something like that? It's about shaping its abilities and making sure it can actually do something useful, right?
Exactly. And this paper highlights two main stages of training.
Mm-hmm.
They call them instruction tuning and alignment tuning. Instruction tuning basically teaches Solar how to follow instructions, like how to understand what we want it to do.
Instead of just setting it loose on all that data.
Yeah. The researchers use this thing called the Alpaca GPT-4 dataset. It's full of real-world examples of like instructions and responses so Solar can learn those patterns.
Makes sense. So you've got it following instructions, but how do you make sure it's not going off the rails?
Yeah.
Making sure it's actually using that knowledge in a way that's good, helpful.
Well, that's where alignment tuning comes into play. It's about making sure Solar's responses aren't just accurate, but also appropriate and unbiased. That they're actually aligned with what we consider good.
So it's not just about being right, but being responsible as well.
Exactly. And this is where things get really interesting. They used a data set called Ultra Feedback Clean for this, which is designed to teach models how to communicate in a way that's aligned with human values. And they went even further with Solar's math skills. They created a special data set called Synth Math Instruct.
Okay, I'm all ears. What's so special about this math data set?
So basically, they took existing math problems and then rephrased them in different ways. The idea is that if the model sees the same math concept expressed in multiple ways, it'll understand it better.
So it's not just memorizing the format of a specific problem, it's actually learning the underlying math.
Precisely. And to really fine-tune its mathematical reasoning, they created yet another data set called Synth. math alignment. This one makes sure that Solar is actually thinking through the problem and not just spitting out random numbers.
It's like showing your work in math class. You have to be able to explain how you got there.
And that's what's so impressive about Solar's performance on these math benchmarks. It's not just about getting the right answer, it's about demonstrating a deeper understanding. And they achieve this with a model that's way more efficient than a lot of the alternatives out there.
Which really makes you wonder what else this depth upscaling approach could be used for. It's not just about efficiency, it's about changing how we think about AI development altogether. So we've got this crazy efficient, surprisingly powerful LLM that can learn complex tasks, reason through problems, and even handle math like a pro home. It makes you wonder what this means for AI, especially since it's open source.
The possibilities are huge. Think about it. Anyone with a decent computer and a good idea could use this technology. We can see a wave of innovation in AI coming from all sorts of places.
It's like that saying, give a man a fish and you feed him for a day. Teach a man to fish and you feed him for a lifetime. Except this is more like give everyone the tools to build amazing AI and see what they come up with.
Exactly. And that's a big part of what's so exciting about Solar 10.7b. The researchers are really challenging that idea that AI development should only happen in a few big companies.
It's about making these tools available to everyone and seeing what they can do. It's about potential.
Absolutely. And even though Solar 10.7b is still relatively new, this research paper gives us a glimpse of what the future of AI could look like. More efficient, more accessible, and ultimately more impactful.
That's what I love about these deep dives. We're not just looking at a cool new gadget. We're getting a sneak peek at a future where AI is a force for good in the world. So as we wrap up, here's a question for everyone listening. What could you do if you had this kind of AI power at your fingertips?
What kind of problems could you solve? What would you create? It's a pretty exciting thought.
It really is. And that's all the time we have for today's deep dive. As always, keep exploring, keep asking questions, and we'll catch you in the next one.
Hey everyone, ready to dive in. Today, we're all about large language models, those AI powerhouses behind things like, ChatGPT.
We're getting into the nitty-gritty of a paper called Solar 10.7b, Scaling Large Language Models with Simple Yet Effective Depth Upscaling.
Yeah, I know. Sounds kind of intense, right? But that's why we're here, to break it down.
Exactly.
So why should we even care about how these LLMs tick?
Well, they're already changing how we write, how we code, even how we think.
No joke.
Yeah.
It's wild how fast things are moving. And what's cool about this research, it's all about making LLMs smarter, not just bigger, which is what everyone seems to be chasing these days.
Right. It's not always about size.
Like imagine the power of a massive LLM, but running on something as simple as your phone.
That's the kind of future this paper hints at.
Seriously cool stuff. But before we go too far, let's define some terms. What exactly is a large language model, an LLM? For those tuning in for the first time.
Think of it like this. An LLM is like a student who's devoured the entire internet.
The entire internet? Well,
yeah, all of it. They've absorbed so much text, so much code, that they start noticing patterns, connections, things even humans miss.
like a super student.
Exactly.
Okay, that makes sense. Now, when we talk about scaling these LLMs, what are we actually talking about?
Okay, so picture this.
Yeah.
You're building with Legos, right? You can always add more bricks to make something bigger.
Sure, makes sense.
But how you connect those bricks, that's what matters. Scaling is about finding the smartest way to build, not just building bigger for the sake of it.
I like that, the how. So true. And that leads us to the core of this Solar research, depth upscaling, or DUS.
Right, and that's how this Solar 10.7b model gets so much right.
So instead of just making the LLM bigger in a general way?
DUS is about choosing very specifically which layers within the model to duplicate and connect, almost like being picky eaters, but with AI architecture.
Interesting. Picky eaters.
The researchers found that by being choosy about what they scaled, they could make a way more efficient system.
And this is where it gets really interesting, right? This smaller, more efficient model actually performs better than some of the massive ones out there.
It's true. They called their approach depth-wise scaling, and if you're looking at the paper, Figure 1 really shows it visually.
So they basically zeroed in on the parts that mattered most.
Exactly. They identified specific layers in the model that, when duplicated, had a bigger impact on performance, like reinforcing the key structural points in that Lego building.
Ah, okay. So it's not just about adding more, it's about adding it strategically.
Exactly. You got it.
So they're strategically adding complexity. But then how does the LLM actually adapt to this new structure?
That's where continued pre-training comes in.
Okay, so like giving it some extra study time.
Yes. After they restructure with the US, they give the LLM more training, time to adjust. What's amazing is how quickly it learns and adapts to this new design.
So we've got a leaner, meaner LLM, thanks to some seriously clever engineering. But for those of us who aren't, AI researchers, what does this actually mean?
That's the important part. This isn't just some theoretical exercise, right? This kind of efficiency.
Right, right.
It could make powerful AI accessible to everyone.
Now that would be huge.
Imagine running really sophisticated language tools, but offline, on your phone, without needing a supercomputer.
Wow. That would be a game changer, especially for folks who don't have access to the latest tech.
Absolutely. And there's something else really exciting here. The Solar 10.7b model, it's open source.
Oh, I love that they did that.
Right. It means that other researchers, developers, they can all see how it works, build upon it, adapt it for new stuff.
Feels like a very collaborative way to approach AI research.
It really is. And that open approach is a huge part of what drives innovation in this field. But hold on, because the team didn't stop at efficiency, they took it a step further. They fine-tuned Solar 10.7b to be amazing at something very specific.
Oh, this is getting good.
They fine-tuned it to be incredibly good at following instructions.
Which, let's be real, is super important for AI if it's going to, actually be useful in the real world.
Totally,
Yeah.
totally. Can't just have it doing its own thing. Got to be able to steer the ship.
Exactly. So it's like they gave their super student specialized training to become, I don't know, even more helpful, adaptable.
Perfect way to put it. They used a two-stage process.
Okay, hit me with.
First, there's instruction tuning,
Which is?
basically. They train the LLM on a massive data set of instructions and responses, teaching it to really understand commands and respond to them effectively.
So like giving it a crash course in how to human.
Exactly. Well, at least how to understand what humans want.
Right, because we're not always the best at giving clear instructions.
That's putting it mildly. But that's where the second stage comes in. Alignment tuning.
Okay, and that is?
This is where they train the LLM to get human values, like to actually understand and prioritize our intentions.
So it's not just following orders, it's understanding the why behind the orders.
Right. It's about responding in a way that aligns with our goals, our expectations, even if we're not great at expressing them.
That's a relief, honestly, because I am not always articulate.
None of us are. But that's what makes this alignment tuning so important. And the results. Really promising.
Okay, I'm ready. Give me the good news.
Solar 10.7b, after all that training, consistently outperformed other LLMs of a similar size.
No way, really?
Yep, showed a remarkable ability to understand and respond to even complex instructions.
So it's not just like a theory, it actually works.
It's the real deal. And this opens up so many possibilities using these LLMs in ways we've only just begun to imagine.
Like what? Give me some examples.
Think about it. Personalized AI tutors that adapt to how you learn best. Or AI assistants that can help automate those really complicated tasks.
Okay, those are cool, but kind of expected, right?
What about AI collaborators? Ones that could help you write a novel, compose music.
Oh, hold on. AI co-authors.
The possibilities are really kind of endless.
Okay, that's amazing. But one thing that keeps blowing my mind is that they made Solar 10.7b open source.
Right, I know. Means anyone can dig into their research, use it, build on it.
That's huge. Like they're sharing their secrets with the world.
Exactly. This kind of openness, it's crucial for collaboration, for speeding up progress in AI.
They're not just presenting the what. They're giving everyone the tools to understand the how.
And that's how we get real innovation, by sharing their knowledge, encouraging people to build on their work. The Solar team, they're helping to make AI something everyone can be part of.
I love that. It's inspiring to see a team so dedicated not just to pushing the boundaries of what's possible, but making sure everyone benefits.
Couldn't agree more. Sets a fantastic example for the whole field.
It really does make you think, what else can we achieve with this kind of open collaboration?
Right. And speaking of collaboration, another thing worth mentioning is the team behind Solar 10.7b itself. You look at the paper, the authors, it's a really diverse, talented bunch.
I was going to say, that's a lot of names.
Yeah, and from all different areas of expertise. You've got machine learning specialists, data scientists, software engineers. It took a village to raise this LLM, basically.
Makes sense. It's such complex stuff, clearly not a one-person job. Yeah, it really highlights how collaborative AI research has become.
Totally. Like, to create something as advanced as Solar 10.7b, You need expertise from all over the place.
It's true. It's not just one field anymore.
Not at all. You've got machine learning folks, data scientists, software engineers, the list goes on. And they're all working together toward this one goal.
Like a well-oiled machine.
More like I guess an orchestra is a better analogy.
Ooh, I like that.
Right. Each person playing their part to create something really remarkable.
And when you add in the fact that they made the whole project open source,
Right. Can't forget that.
that just takes it to another level.
It really does. They're not just sharing their results. They're giving everyone the tools to explore, experiment, build on their work. That kind of transparency, it's huge for innovation in AI.
It's like they're saying, here's the blueprint, now go build something amazing. So cool.
Seriously, it speaks volumes about their commitment to moving AI forward as a whole.
So as we start to wrap up here, what would you say is the biggest takeaway for our listeners today? What should they be thinking about as they go about their day?
That's a good question. For me, the thing that really sticks out is that we're just scratching the surface of what's possible with LLMs. Solar 10.7b, it challenges this idea that bigger is always better in AI.
Which seems to be the prevailing wisdom these days.
Right. But by focusing on efficiency, on clever engineering, on collaborating openly, they got incredible results with a relatively small model. That's huge. It opens up all these new possibilities for the future of AI. More accessible, more efficient, more impactful applications. It's exciting.
It is. It reminds you that the future of AI, it's not some like predetermined thing. We're all actively shaping it with every line of code, every research paper, every new idea.
Exactly. It's a team effort.
It really is. And who knows, maybe someone listening right now will be the one to take Solar 10.7b even further to create the next breakthrough in AI.
Now that would be something, wouldn't it?
That's all the time we have for today's deep dive, but the conversation doesn't end here. Tell us your thoughts on Solar 10.7b and the future of LLMs. Until next time, keep exploring, keep learning, and keep asking questions.
Okay, so large language models. You know those AI systems that seem to be everywhere you look these days? Maybe you're kind of curious about this whole LLM thing, but the tech stuff kind of makes your eyes glaze over a little.
Yeah.
I get it.
That's exactly why we're diving into Solar 10.7b, scaling large language models with simple yet effective depth upscaling.
It's a mouthful, I know, but stick with me here. This paper is way more exciting than its title makes it seem.
It really is fascinating. It delves into some really clever techniques to make these powerful AI models, well, more, how do I put it, user-friendly.
Okay, so we're talking about making LLMs bigger and smarter, right? Like literally giving them a brain boost.
You got it. Imagine scaling an LLM like upgrading your computer's RAM. We're increasing the size and complexity, usually by adding more parameters, which are essentially the connections between the artificial neurons in the model's brain. Now, generally, more parameters equals better performance, but it also makes the model way more resource intensive. And that is one of the big challenges the Solar paper is tackling head-on.
So instead of needing a supercomputer to run these massive AI models, Solar is going for something more streamlined. That's already got my attention.
Exactly. And that's where their secret weapon comes in this technique they call depth upscaling. DUS for short. Instead of building a giant model from scratch, they cleverly utilize the knowledge already present in smaller pre-trained models. Think of it this way. You wouldn't build a skyscraper starting with individual bricks, right?
Right. You'd use prefabricated sections to make the process way faster and more efficient.
Exactly.
So the researchers behind Solar, what were they hoping to achieve with this LLM? What makes it different from everything else out there?
Well, their goal was certainly ambitious but practical. They wanted to create an LLM that was powerful for sure, but also efficient and accessible. Here's an analogy. Anyone can build a gas-guzzling monster truck, right? Solar is going for something more like a sleek, high-performance electric car.
I like that analogy. Okay, so they're not just focused on raw power, but also on making that power usable in the real world.
You got it.
And that's where this whole DUS thing comes in.
Exactly. DUS lets them essentially upscale existing LLMs, making them bigger and smarter without needing to start from scratch. Imagine you've got a well-organized library. Now, instead of adding a whole new wing, you very carefully make copies of some of the most insightful books, and you strategically interleave them to make a taller, denser collection of knowledge. That's depth-wise scaling in a nutshell.
So instead of building a whole new library, they're making the existing one even more insightful, if that makes sense. But you also mentioned continued pre-training. Why is that step even necessary? Isn't this new, bigger library good to go?
That's a great question. So scaling the model definitely unlocks a lot of potential, but it needs to be organized for that potential to be realized.
Yeah.
Think about it. You wouldn't just add a bunch of books to a library haphazardly and expect to find anything easily.
No way.
That's where continued pre-training is crucial. It's like bringing in expert librarians to organize and index all the new books to make sure all that information is easily searchable and retrievable.
So it's about making sure the LLM can actually use its newfound knowledge effectively.
Exactly. Continued pre-training helps the LLM navigate that huge expanded knowledge base and use it effectively.
So this whole DUS approach sounds clever and all, but does it actually work? How does Solar actually stack up against some of the other big names in the LLM world?
That's the real question, isn't it?
Right.
Well, they really put Solar through its paces. They benchmarked it against other top LLMs on things like question answering, reasoning, even common sense understanding, which is, believe me, that's not easy for AI.
Don't leave me hanging. How'd it do?
Solar actually outperformed models that were significantly larger than it was. And what's really impressive is that it manages to do this while being a lot more computationally efficient. Imagine like a lightweight electric car going up against like a gas-guzzling SUV in a race and winning.
Okay, you've got my attention.
It really shows you the power of smart design over just brute force.
Yeah. So we've established that Solar is both powerful and efficient, but the paper also digs into how the Solar team actually achieved these results. And they were really deliberate about their methods, weren't they? Right down to the model architecture.
Oh, absolutely. They could have started with any number of existing LLMs, but they chose to build Solar on top of the Llama 2 architecture. But, and this is where it gets really interesting, they initialized it with pre-trained weights from Mistral 7B.
Okay, so what does that even mean?
So it's kind of like they took the best features from two different high-performance cars and combined them to create a hybrid with even better performance.
So they were really looking at the strengths of each model and combining them to create something truly exceptional.
Precisely. And they did something very similar when it came to the depth-wise scaling itself. They didn't just like mindlessly duplicate layers. They strategically removed a certain number of layers from both the base model and its duplicate before putting them together.
Now that sounds a little counterintuitive. If you're trying to make the model bigger, why remove layers?
Okay, so think of it this way. Imagine you're putting together a dream team, right? For, let's say, a really complex engineering project. You wouldn't just assemble this massive team with a ton of experts who all have the same skills, would you?
Right, no.
You want to carefully select people with complementary expertise to make sure things run smoothly and avoid redundancies. That's kind of what this Solar team is doing here. By removing those layers, they're making sure there's a smoother transition and less chance of discrepancies between the old knowledge and the new knowledge. It's really about quality over quantity. They made sure every layer in that scaled-up model is actually doing something useful.
So it's all about creating a more efficient architecture even as the model gets bigger.
Exactly.
Kind of like fine-tuning a really high-performance engine to get the maximum power and efficiency.
Precisely. And speaking of efficiency, their approach to training is another great example of how meticulous they were. They were laser-focused on using high-quality data sets rather than just throwing a ton of data at the problem.
Data is so important for any AI model.
It really is.
So what were some of the data sets they used to train Solar?
They used a bunch of existing open-source data sets,
Okay.
which is really great for transparency and reproducibility. It means other researchers can understand what they did and even build on their work. But they didn't stop there. To really boost Solar's math skills, they took it a step further and created their own custom data set that was specifically designed to improve its mathematical reasoning. They called it SYNth, Math Instruct.
SYNth. Math Instruct, I like it. It sounds like they gave Solar specialized tutoring to make it an absolute math whiz instead of just hoping it would pick it up on its own.
Exactly. It's like the difference between giving a student access to a huge library and actually providing them with like a well-structured textbook and some really targeted practice problems.
Right.
And the results really speak for themselves. Solar showed massive improvement in its ability to handle complex math problems, even beating out larger models that didn't have that specialized training.
So it's not just about the size of the model, it's about the quality of the data and how it was trained.
Absolutely. It's about being smart with the data you use and making sure it helps the model learn as efficiently and effectively as possible. And this whole focus on quality over quantity is really clear in their two-step approach to fine-tuning Solar. So first, they focused on something called instruction tuning, basically teaching it to be a model student by making sure it could follow instructions really well.
So making sure it could follow directions before they let it loose on the world makes sense to me.
Right. And for this step, they used a mix of data sets, including, you guessed it, their custom synth math instruct set. Then came alignment tuning, which might sound kind of ominous, but it's actually super important to make sure AI development is done responsibly.
Alignment tuning, it does sound kind of like something out of a sci-fi movie where we're trying to stop robots from taking over the world.
Yeah, it does.
But seriously, what does that even mean?
Well, you're not far off. Basically, alignment tuning is all about making sure that Solar's responses are things that we humans would consider good, helpful, and unbiased. It's about making sure the AI is using its powers for good, so to speak.
Right. We don't want our AI going rogue. So how do they go about making sure Solar was, ethically sound?
They use something called SDPO, and the PIAS stands for supercharged. Supercharged DPO, which stands for Direct Preference Optimization.
Supercharged DPO. Okay, that definitely sounds a lot cooler than plain old DPO.
Right. Gotta love a good AI jargon upgrade. Without getting too technical here, SDPO basically trains the model to favor responses that humans have rated highly. So instead of using complex reward systems or reinforcement learning, it takes a more direct approach, relying on good old-fashioned human feedback.
So it's like they're showing Solar examples of good AI behavior and saying, this is what we're looking for. Learn from this.
Yes, exactly. And they were so thorough about it, they even went the extra mile to test for something called data contamination.
Data contamination, that's a new one. What does that even mean?
Okay, so imagine you're a teacher and you're about to give your students a big exam, right? You want to make sure they didn't cheat and peek at the answer key beforehand. That's kind of what data contamination is like. They wanted to make sure that Solar wasn't just memorizing answers from the benchmark data sets. They wanted to make sure it was actually understanding the prompts and coming up with its own responses.
So they were verifying that it could actually understand, not just repeat stuff back.
Exactly. And I'm happy to say Solar passed with flying colors. They proved that it can not only process information, but actually understand it and reason based on what it's learned.
So it's like they put Solar through this really intense vetting process to make absolutely sure that it was the real deal and not just some really clever test taker.
Yeah.
But for all of you listening out there, what's the big takeaway here? Why should this research matter to you even if you're not like an AI expert?
For me, it's the elegance, the sheer thoughtfulness that really stands out. The Solar team didn't just throw a bunch of processing power at the problem and hope for the best. They thought really carefully about every single aspect of it, from the architecture to the data they used for training.
Yeah.
And they came up with some really innovative solutions.
Yeah.
It really challenges that whole bigger is always better mentality that we see so much of in AI.
It's like they were optimizing for ingenuity rather than just sheer size. And that's really significant, isn't it? Because it's not just about making AI that's smarter. It's about making AI that everyone can actually use.
Exactly. And this whole idea of depth upscaling, using smaller models and really prioritizing efficiency, that can be huge, especially as we're trying to figure out how to make powerful AI more sustainable and more accessible for researchers and developers who don't have unlimited resources.
So it's really about democratizing access to these cutting-edge tools. Instead of needing a tech giant's budget to work with these LLMs, smaller teams could use Solar to actually make a difference in the world.
Absolutely.
Imagine a small research team using Solar to develop some kind of AI-powered tool for, like, translating ancient languages. It could open up whole new avenues for research that we haven't even thought of yet.
Exactly. Or imagine doctors using it to come up with personalized cancer treatments that are based on a patient's own unique genetic makeup. There are so many possibilities.
It's pretty amazing when you think about it. It's like Solar is breaking down the barriers to entry for groundbreaking research. Instead of needing a supercomputer, you might be able to run these powerful models on like a high-end gaming PC.
Exactly. And that idea, making advanced AI tools available to everyone, that's what I find so exciting. This isn't just some theoretical research project. This has the potential to really change the world.
This whole deep dive has been incredibly eye-opening, to say the least. But before we wrap up, what's the one thing you really hope our listeners take away from all of this?
Don't just focus on how big and powerful a model is. Pay attention to the process, how they actually got there. Solar is a perfect example of how innovation can come from unexpected places. It's about working smarter, not harder, and being open to trying new things, even if they go against conventional wisdom.
Those are definitely words to live by, especially in a field like AI that's constantly evolving. So to all of you listening, the next time you see a headline about a massive new language model, remember Solar. Remember that bigger isn't always better. Sometimes the most elegant solutions come from thinking outside the box, or in this case, thinking inside the library. Until next time, happy learning, everyone. Hey everyone, welcome back. Ready to dive in? Today we're tackling a pretty big deal in AI. We're talking large language models, or LLMs for short.
Yeah, those AI systems that are designed to, understand and generate text like we do.
Exactly, and there's been a pretty significant development in that world. Solar 10.7b.
And it's not just like a small step forward. This has the potential to really change how we think about building these complex AI models.
For sure. We've actually got the research paper right here, and the stuff they're doing with Solar 10.7d is impressive. And get this, it's open source, available under the Apache 2.0 license, which is huge.
It is. That kind of accessibility is going to be a game changer for so many developers and researchers.
Absolutely. So let's get into it. What makes Solar so special?
Well, at the heart of it is this really clever scaling method they've developed called DUS. It stands for depth upscaling.
DUS. Okay. Scaling these massive language models efficiently is a major challenge, so I'm really interested to hear how this works.
Right, and it's actually a pretty elegant approach. Think of it like building with Legos, right?
Sure.
You start with a solid base, and in this case, that's the existing Mistral 7B model. Then instead of building outwards, you go upwards, layer by layer, hence the depth-wise scaling.
So you're carefully adding layers on top of an already strong foundation. Sounds like they're prioritizing quality over just sheer size.
You got it. But there's one more crucial step. The final part of DUS is all about fine-tuning that whole model, ensuring it's stable, and performing at its peak.
Like adding those final touches to your Lego masterpiece and making sure everything runs smoothly. That's really cool. But haven't there already been ways to scale these models? Why is DUS such a big deal?
You're right, there have been other methods, but a lot of them, like Mixture of Experts or MOE, are really, really complex.
I see.
DUS, on the other hand, is surprisingly straightforward.
Interesting.
And that makes it so much easier for developers to actually use it effectively.
So simpler design, easier to implement, but how does it actually perform? That's what really matters, right?
And that's the really exciting part. Solar 10.7b, it's not just efficient, it's seriously powerful.
Okay, so spill the beans. How powerful are we talking?
We're talking outperforming models twice its size, like on benchmarks like MMLU, which is all about testing reasoning skills across different areas.
Wait, it can outperform models twice its size. That's incredible.
It's a huge deal. And it gets even more interesting. Remember how we talked about DUS and how it allows for that fine-tuning step?
Yeah.
Well, they actually created Solar 10.7b Instruct.
Yeah.
Basically a version that's specifically fine-tuned to be amazing at following instructions.
Interesting. So not just understanding and generating text, but actually being able to follow complex instructions?
Exactly.
What does that look like in action?
So imagine you give it a task like, write me a short story for a children's book about, I don't know, a robot that learns to bake cakes.
Okay.
Solar 10.7b Instruct. It can not only understand that, but it can actually generate really creative text tailored to that audience and that genre.
Wow, that's really impressive. And I'm glad we're also talking about the ethical considerations
Right.
because those are so important.
Absolutely. The team behind Solar 10.7b were really conscious of things like data contamination, which can really mess up your results.
Yeah, data contamination. Explain that for me one more time.
It's basically like if you were taking a test and you'd already seen the answers, right? It doesn't really show true understanding.
Right, like memorizing the answers instead of learning the material.
Exactly.
It makes sense. So they were really careful to avoid that with Solar 10.7b. We want these AI tools to be reliable. We got to be able to trust them.
For sure. And the paper really digs into all the ways they went about minimizing that contamination. It shows they're really committed to building ethical AI. It's not just about raw performance. It's about doing things the right way.
Totally. So to wrap things up a bit, we've got this incredibly capable, ethically developed LLM in Solar 10.7b, and it's open source, so the potential here is just massive. What are you most excited to see people create with this?
That's the really exciting part, right? It's like we're giving people this incredible new toolbox and saying, go build something amazing. We could see much better AI assistants, ones that truly get what we need, or even educational tools that can adapt to different learning styles. I mean, the possibilities are kind of endless.
I love that, like handing someone a box of those really advanced futuristic Legos and just saying, go wild, surprise me.
Exactly. And because Solar is open source, it's really going to foster that spirit of collaboration. It's not just a few big companies controlling the future of AI. It's going to be a global community of innovators all working together.
And that's a really powerful idea. So as we kind of wrap up our deep dive into Solar 10.7b, What's your biggest takeaway? What's the one thing you really want our listeners to walk away remembering about all of this?
I think for me, it's that really powerful combination of groundbreaking performance with a really strong ethical foundation.
Yeah.
Solar 10.7b proves we can push the boundaries of what AI can do without compromising our values.
Yeah,
That's incredibly encouraging for the future.
it really is. It reminds us that the future of AI isn't set in stone. It's something we're all actively creating together, one breakthrough at a time. And on that note, that's a wrap on this deep dive into Solar 10.7b. We'll catch you next time for another exciting exploration into the world of AI. Hey everyone, buckle up because today we're diving headfirst into the world of AI.
Specifically, something called Solar 10.7b.
Okay.
You know how ChatGPT is all the rage?
Right.
Well, this is like its super smart cousin just arrived on the scene.
Yeah, and it's causing quite a stir.
What's really interesting about Solar 10.7b is that it's not just a little bit better than what we've already got.
It's tackling a fundamental problem in AI.
Mm-hmm.
How to make these models more powerful without needing a supercomputer the size of a small country to run them.
Okay, that sounds like a pretty big deal, but how does it actually work?
The research paper mentions something called depth upscaling,
Right.
which honestly sounds a bit like a sci-fi movie plot.
It does, doesn't it? Imagine you're building a skyscraper.
Instead of making the base wider and wider, which takes up a ton of space and resources,
Yeah.
you find a way to add more floors, building upwards.
That's essentially what depth upscaling does.
It makes the AI deeper rather than wider.
So instead of just throwing more computing power at the problem.
The creators of Solar found a more elegant, efficient solution.
Yeah.
That's fascinating. But does it actually make the AI smarter?
That's the million-dollar question, right?
Yeah.
And the answer seems to be a resounding yes.
Solar has blown researchers away with its performance on all sorts of tests.
From reasoning and math to understanding complex instruction.
Okay.
It's even outperforming some of the bigger, more established AI models out there.
Okay. Color me impressed.
So we're not just talking about a minor upgrade here. This depth thing seems to be a game changer.
Yeah.
But let's break it down a bit further.
What kind of tasks can Solar actually do?
What makes it different from, say, ChatGPT?
One of the most exciting aspects of Solar is its ability to follow instructions in a really advanced way.
Think about how we interact with AI now.
We give it prompts, and it tries its best to understand and respond, right?
Right, like asking it to write a poem or summarize an article.
Exactly.
But instruction following takes this to a whole new level.
It's about training the AI to understand and execute really complex multi-step instructions accurately and reliably.
Imagine you ask your AI to plan a vacation.
Not just suggest destinations, but actually book your flights, find you the perfect hotel based on your preferences, and even write personalized postcards to send home based on what it finds online about the places you're visiting.
That's the kind of future this technology hints at.
Okay, that's both incredibly cool and a tiny bit terrifying all at the same time.
I mean, on the one hand,
Yeah.
it could make our lives so much easier.
But on the other hand, it's like, are we ready to hand over the reins that much?
But before we spiral into a sci-fi existential crisis,
Let's talk about how Solar actually learns to follow instructions.
the paper mentioned something about continued pre-training,
Right.
which kind of sounds like some sort of intense AI boot camp.
It kind of is. Remember the skyscraper analogy?
Well, imagine after you've added all those extra floors.
You need to make sure everything is connected and working together seamlessly.
Right.
Continued pre-training is like fine-tuning all those intricate connections in Solar's brain.
Teaching it to learn even more effectively from the data it's given.
So it's like taking a bunch of really smart individuals and turning them into a highly skilled, synchronized team.
Exactly. And that's a big part of what makes Solar so good at what it does.
Okay, so far so good.
But how do we know Solar isn't just a really good parrot
I mean, how can we be sure it's actually understanding the instructions?
and not just spitting out something it's seen before?
That's a question that keeps AI researchers up at night. We'll dive into that more in the next part of our deep dive.
But suffice to say, the creators of Solar were very aware of this concern
Oh,
and took steps to ensure Solar wasn't just a clever mimic.
Okay, now you've really piqued my curiosity. I can't wait to dig into that.
But before we move on,
Can you give us a real-world example of how this instruction-following superpower could actually be used?
let's take healthcare.
Imagine a doctor who needs to analyze a complex medical case with mountains of data. Patient history, test results, the latest research.
Solar 10.7b Instruct, which is a fine-tuned version of Solar specifically designed for instruction following.
Okay.
Could process all of that information.
Identify potential red flags, suggest possible diagnoses.
And even outline different treatment options with their potential benefits and risks,
So it's like having a superpowered assistant by your side.
helping you navigate through all the complexities.
Precisely. And that's just one example.
We're talking about potential applications in any field where processing massive amounts of information and making complex decisions is critical.
From finance and education to law and beyond.
This depth upscaling thing is starting to sound like it could be a real game changer.
But before we get too carried away, imagining all the possibilities.
Let's take a closer look at the nuts and bolts of how this whole thing actually works.
So we left off talking about Solar's ability to process massive amounts of information and make complex decisions.
But how does it actually do that?
Yeah, that's the real question here, right?
Right.
Remember how we talked about Solar being built like a skyscraper with layers?
Right.
Well, those layers are key to understanding its power.
Yeah, the whole depth upscaling thing, it sounded intriguing.
But I'll be honest.
I need a little more than a skyscraper analogy to wrap my head around it.
Fair enough. Think of it like this.
Imagine Solar's brain is like a network of those super efficient delivery services.
Okay.
You know, the ones that zip packages across the city at lightning speed.
Right.
Information flows through this network.
And the system learns to prioritize the most important routes.
That's essentially what the transformer architecture does.
It helps Solar process and understand information in a really sophisticated way.
Okay, that's a much more relatable analogy.
So these like layers in the skyscraper are like different departments in the delivery service.
Each handling a specific part of the process.
You got it.
And what the creators of Solar did was figure out a way to make this delivery service even more efficient.
Not by just adding more trucks or delivery drivers, which is what a lot of other AI models do.
Right.
But by optimizing the routes and making the system itself smarter.
They found that by adding more layers in a strategic way,
Okay.
they could make Solar much better at understanding complex relationships in the data.
So it's not just about the amount of information,
Right.
but about how deeply Solar can...
Understand and connect the dots between different pieces of information.
Exactly.
That's pretty amazing.
It's like the difference between skimming a book.
And really diving deep into every chapter.
Right.
Analyzing the characters.
The plot, the themes.
Solar is designed to be a deep thinker.
Okay, that makes a lot of sense.
But you mentioned earlier that they actually remove some layers in this process.
Right.
That seems a little counterintuitive.
Yeah.
If you want to make something smarter, shouldn't you be adding more, not taking things away?
That's where it gets really clever. It's not just about blindly adding layers.
It's about finding the most efficient and effective structure.
Okay.
They start with a base model.
Think of it like a solid foundation for their skyscraper.
Yeah.
And then strategically duplicate and prune layers to create a larger, more powerful structure.
So it's more like sculpting than just stacking blocks on top of each other.
Precisely.
And they found that this specific way of moving and connecting layers
Led to even better performance during the continued pre-training phase, which we talked about earlier. It's like fine-tuning an orchestra.
You want every instrument to be in perfect harmony to create the most beautiful music.
Right, that makes sense, but why go through all that trouble?
Why not just stick with the original smaller models?
Yeah.
If they're already pretty good.
Because as amazing as those smaller models are...
They still have limitations.
Okay.
They hit a ceiling in terms of how much they can learn and how complex their reasoning can become.
Depth upscaling allows researchers to push past that ceiling and unlock new levels of AI intelligence.
It's like the difference between having a conversation with a chatbot that can answer basic questions.
Right?
And having a conversation with someone who can truly understand your perspective,
Yeah.
challenge your assumptions,
Exactly.
and help you see things in a new light.
And in Solar's case, this translates into some pretty remarkable abilities.
Like we were talking about earlier, its ability to analyze complex medical data
Yeah.
or plan a vacation down to the smallest detail.
Okay, I'm starting to see why this is such a big deal.
But if this depth upscaling technique is so effective,
Why aren't all AI researchers using it? What's the catch?
well, it's still a relatively new approach.
It's like discovering a new, more efficient way to build a spaceship.
Okay.
It's incredibly exciting, but you need to make sure it actually works before you start sending people to Mars.
The researchers who created Solar have essentially given the world a blueprint for this new kind of AI.
And now other researchers are busy studying it, testing it,
Okay.
trying to understand its full potential.
So it's like opening a new door in the world of AI.
And we're just beginning to explore what lies beyond.
Exactly. And that's what makes this field so captivating.
There's always something new to discover.
Speaking of discoveries,
You mentioned that Solar 10.7b aced some really challenging tests.
can we delve into those a bit more? I'm curious to see what kind of tasks this model was able to handle.
That other AI struggled with.
Okay, so let's talk testing.
How do we know Solar can actually walk the walk?
Well, in the world of AI, there are these benchmark tests.
Kind of like the AI Olympics. Researchers use them to see how their models stack up against the competition in different areas like reasoning, common sense.
Even math skills.
So, did Solar take home the gold?
It definitely turned heads. One of the tests, called ARC, focuses on scientific reasoning.
Imagine trying to answer a multiple-choice science question where you have to really think critically and apply your knowledge.
Right.
A lot of AI models struggle with that.
But Solar aced it, even beating out some much larger models.
Wow, that's impressive.
Sounds like Solar is more than just a one-trick pony.
Exactly. It also did incredibly well on a test called HelloSwag.
Which measures common sense reasoning.
Okay.
You know, those everyday situations where you just kind of get what's going on, even if it's not explicitly stated.
Right.
That's a tough one for AI to grasp.
Because it requires understanding those subtle nuances of human language and social interaction.
It's like those, what's the next logical step? Puzzles, but for artificial intelligence.
Yes. And then there's MMLU.
The real monster of a test.
Okay.
It covers a huge range of topics, from history and law to computer science.
Wow.
Solar held its own.
Proving it can handle a wide variety of subjects.
Okay, so maybe not a gold medal in every event, but definitely a strong all-around competitor.
Exactly. And that's what's so remarkable.
It achieved these incredible results with a relatively small size.
Compared to some of the AI behemoths out there.
It's like finding a way to build a super efficient engine that can power a race car to incredible speeds without guzzling fuel.
Precisely. This depth upscaling technique
Suggests that we can achieve amazing things with AI.
without needing massive amounts of computing power.
Yeah.
It's about working smarter, not just bigger.
So what does this mean for the future? Are we going to see a whole new generation of super smart, super efficient AIs popping up everywhere?
It's definitely a possibility.
Remember, this is still a relatively new area of research.
Right.
But the early results are really promising.
Solar is like a glimpse into the future of AI.
A future where these systems are not just tools, but collaborators,
Yeah.
helping us solve complex problems, unlock new possibilities.
And maybe even understand ourselves a little better along the way.
It's both exciting and a little bit daunting at the same time.
It is. But that's the nature of any powerful new technology.
It has the potential to change the world in profound ways,
Right.
and it's up to us to guide its development responsibly and ethically.
Well said. It definitely gives us a lot to think about.
If Solar 10.7b has taught us anything.
It's that the world of AI is full of surprises. Who knows what amazing breakthroughs are just around the corner. That's all the time we have for today's deep dive. Thanks for joining us.
Ever feel like trying to cram an entire library into your brain?
Oof. Yeah.
That's kind of what we're asking AI to do with these large language models, LLMs.
Yeah.
The things that power chatbots, write different kinds of creative content. But here's the thing. Bigger doesn't always mean better, even in AI.
Yeah.
And that's where this deep dive gets really interesting.
Okay.
We're looking at this paper, Solar 10.7b, scaling large language models with simple yet effective depth upscaling.
Right.
This team basically found a smarter way to build a better AI brain.
Yeah.
And it's not just about throwing more data or computing power at the problem.
It's really interesting what they're doing here, actually. It's like, imagine if
It's fascinating.
you were building a skyscraper. You wouldn't just stack identical floors on top of each other.
Okay, I see where you're going with this. So it's about designing for efficiency, different levels, serving different purposes.
Exactly. And that's what they're doing with this new technique
Okay.
called depth upscaling, or DUS.
DUS.
They actually start with an existing LLM, and then they strategically duplicate and remove layers.
They remove layers.
Yeah.
That seems counterintuitive. If you want a more powerful model, wouldn't you add more layers, not take them away?
This is where it gets really clever.
Okay.
See, it's not just about the number of layers. It's about the relationship between them.
Okay.
The paper talks about something called layer distance.
Layer distance.
Think of it like this. Imagine you have a company where everyone went to the same school and learned the same things.
Okay.
Sure.
So you'd have a lot of people who are great at the same thing. But what about everything else?
Precisely. You might have an amazing marketing team, but what about finance or engineering? Diversity is key. And in the case of LLMs, that diversity comes from having a good layer distance.
Okay.
Too much similarity between layers, and the model actually struggles to learn new things effectively. It's like everyone's thinking the same way, so there are fewer opportunities for new insights or perspectives.
So how does the Solar team know which layers to duplicate or remove? Can't just be random.
Absolutely not. This is where their process is really impressive. They do a deep analysis of the model's existing architecture to identify what they call redundant layers,
Okay.
ones that aren't contributing unique learning capabilities.
So they're essentially streamlining the model, removing the parts that aren't adding anything unique to the overall learning process.
Exactly.
You know, this reminds me of bonsai trees.
Okay.
I actually tried to grow one once. Let's just say I learned the hard way. You can't just hack away at the branches.
Yeah.
It's an art.
Yeah.
You have to prune strategically to create a more beautiful, and in the case of bonsai, a much healthier tree.
Yeah, yeah.
And it sounds like DUS is doing something similar with LLMs, shaping them for optimal learning.
Exactly.
Okay, so we've got this taller, more streamlined LLM,
Right.
thanks to DUS,
Yeah.
with layers strategically placed for optimal learning.
Right.
But here's the thing about building a better brain.
Yeah.
It's not enough just to change the structure. You have to
Right.
teach it how to learn in this new, more efficient way.
It's like upgrading from an old computer to a brand new one. It has all this potential, but it needs the right software and a little time to adjust.
Right.
And that's where the second phase of DUS comes in.
Okay.
Continued pre-training.
Now, this is where things got really fascinating for me.
Okay.
Because the paper mentions that right after they scale the model using DUS.
Yeah.
Remember, it's taller now, but with fewer, more strategically placed layers.
Right.
It actually performs worse than the original.
Huh.
Like it's gone through all this restructuring, and it's actually less efficient at first.
Yeah.
That seems counterintuitive.
It makes sense if you think about it this way. Imagine you've been dancing the waltz for years, and then suddenly someone introduces the tango.
Okay.
Different steps, different rhythm, a whole new way of moving. You're going to be a little clumsy at first, right?
Yeah, that's a great analogy. So
Yeah.
it's like the model is getting used to a whole new way of processing information.
Exactly. All those connections between layers are different now. The flow of information has changed. It takes time for the model to recalibrate, to learn how to use its new architecture effectively. It's like learning a new language. It's going to be a bit bumpy at first, but with practice, you become fluent.
And the paper emphasizes how quickly this fluency emerges during the continued pre-training.
Right.
They're not just waiting around for weeks for the model to catch up.
That's the really exciting part. The speed of the recovery is a strong indicator that the DUS process has done something remarkable. It hasn't just created a bigger model. It's created a model that's inherently better at adapting and learning. It's like they've unlocked a new level of learning potential within the AI itself.
Okay, so we've got this redesigned, retrained LLM.
Right.
Showing some serious learning potential.
Yeah.
But the real question is,
Yeah.
does it actually deliver?
Right.
Can it go head-to-head with the big leagues of the AI world?
This is where the rubber meets the road, right?
Right.
And the Solar team did not hold back.
Yeah.
They put Solar 10.7b up against some of the biggest names out there.
Okay.
Llama 2, Mistral 7b, to see how it would stack up in real-world tasks.
So no pressure then. What were the results like? Give me the highlights.
Well, if you go to Table 2 in the paper... Okay.
It's like the scorecard for a heavyweight AI boxing match.
Okay.
They've got Solar's performance broken down across all these different tasks on something called the Open LLM leaderboard.
Right.
And what's incredible is that Solar 10.7b consistently punches above its weight class.
Really?
You see, in the LLM world,
Yeah.
size is usually king.
Right.
The more parameters, the more impressive the model.
Right, yeah.
But here's Solar 10.7b,
Yeah.
smaller than some of its competitors.
Yeah.
And it's beating them on some pretty complex tasks.
So it's not just about size anymore. This little model that is showing that clever design and efficient training can really outperform brute force.
Yeah.
That changes everything. What does this mean for the future of LLM development?
This is what has the whole AI community buzzing.
Yeah.
Solar 10.7b's is like a proof of concept.
Okay.
They're just scratching the surface of what's possible with LLMs.
Yeah.
And here's the best part.
Okay.
The Solar team made their model and the code completely open source.
Which, for anyone who isn't knee-deep in the AI world, is like finding a winning lottery ticket and then sharing the numbers with everyone.
Exactly. And this open source approach is huge.
Yeah.
It means researchers all over the world can study Solar 10.7b, see how it works, and even build on it to create even more efficient and powerful AI.
Wow.
This kind of collaboration could accelerate progress in AI significantly,
Yeah.
leading to breakthroughs that, frankly, we can only dream of right now.
So to wrap things up, this deep dive has shown us that when it comes to AI, bigger isn't always better. Depth upscaling, this idea of strategic design over brute force computing power, is showing some seriously exciting results. And the fact that this research is being shared openly means we might be on the cusp of a new era of AI innovation, one that's more collaborative, more accessible, and ultimately more beneficial for everyone. Who knows what incredible things AI will be able to do in the future, especially with this kind of efficient design leading the way. Hey everyone, I am so ready to dig into this new research you sent over. Let's talk about Solar 10.7b. It sounds huge and impressive, right?
Yeah, it definitely sounds like something out of science fiction, but it's real, and it's a fascinating look at how we're building the future of AI.
Okay, so walk us through this. Solar 10.7b, this big new language model, what's the big deal?
Well, in the world of LLMs, bigger isn't always better. And Solar, this one, it's not really about the size, you know?
So what is it about then? What makes it special?
It's the way they built it, this whole new approach they're calling depth upscaling. That's the really exciting part. Imagine instead of building out, they're building up.
Building up, so like adding floors to a skyscraper instead of expanding the foundation.
Yeah, exactly. They're taking a smaller, really solid model and basically stretching it, adding layers of complexity in a very precise way.
So it's like they've found a more efficient way to level up AI.
You got it. And what's really cool about this, for everyone listening, is that it could mean we see more advanced AI capabilities even sooner than we thought.
That's exciting. So it's less about Solar taking over the world and more about it being like a stepping stone.
Precisely. It's about making AI more powerful, but also more efficient and accessible for everyone for all kinds of different uses.
Got it. So it's not just another chatbot.
No, it can be used for things like that,
Good
but it's
one.
much more than that. This model excels at things that are really complex, like logical reasoning, solving really tough math problems, and following complicated instructions.
Okay, now that is impressive. But how do they do it? How do they make it so smart? What's this depth upscaling thing all about?
Well, imagine taking a smaller AI model, one that's already really good at what it does, and instead of starting from scratch with a bigger one, you essentially stretch it.
Stretch it.
Yeah, you add layers of complexity, but in a very carefully calculated way. That's depth upscaling in a nutshell.
So instead of building outwards, they're building upwards, like we were saying earlier, like adding those floors to the skyscraper.
Exactly. And this is really important because it avoids all the problems you get with other methods. Like there's this thing called a mixture of experts, right? And that can get really messy. It's like trying to manage a team where no one speaks the same language.
Yeah, that sounds like a recipe for disaster.
It can be. But depth upscaling, this new method, keeps everything nice and streamlined, really efficient.
Makes sense. So you're saying if you can build on a strong foundation, why not?
Yeah.
But it's not just about adding layers, right?
Yeah.
There's also this continued pre-training. What is that all about?
Right, so you can build a fantastic skyscraper, but if the wiring and the plumbing aren't hooked up right, it's not going to be very functional.
So continued pre-training, it's like making sure everything inside this AI skyscraper is working together, all the systems.
Exactly. It's like fine-tuning a really complex machine while you're also expanding it, right? Making sure it doesn't lose any of its capabilities.
And they actually shared what happened when they were doing this continued pre-training. That's kind of unusual, right, for researchers to be so open about the process.
It is, and what they found is really interesting. They said that Solar's performance actually got worse at first.
Really? It got worse? Like before it got better? That seems counterintuitive.
It does, doesn't it? But when you think about what's going on inside the model, it kind of makes sense. It's like we're pushing Solar outside of its comfort zone, you know, forcing it to learn all these new connections between everything it already knows. Think about a time when you were learning something new, a new skill. Often, you get worse before you get better.
That's a good point. It's like Solar's going through a growth spurt or something. A little awkward at first, but then boom, it's excelling. So how does it recover from that initial dip then?
That's where this continued pre-training is so important. It helps solar adapt to its new, larger form and does it really quickly. It's like it suddenly understands all the potential of these new connections, and then it just takes off.
That's amazing. But you know me, I always want to know, so what? What does this mean for people like me? I'm not an AI researcher. The paper mentions how well solar did in these different tests, but how could it actually impact our lives? What are we talking about here?
This research isn't just about bragging rights in the AI world, right? It's about unlocking all these new possibilities. And because this depth upscaling is so efficient, we could be seeing Solar or other models that use this method showing up in real-world applications much sooner than anyone expected.
Okay, give me some examples. What kind of real-world stuff are we talking about here?
Well, imagine a chatbot, but not just any chatbot. This one can help you write a novel based on your ideas. Or a tool that can take all this complex financial data and explain it so that anyone can understand it.
That would be amazing.
Right. Or how about personalized education software that actually adapts to each student's learning style? Or imagine even more powerful tools for scientific research that can analyze data and even generate hypotheses much faster than we can now. There's so much potential here.
So this depth upscaling, it's not just some cool trick. It could actually be the key to making AI useful in all kinds of fields.
Absolutely. This is definitely something to pay attention to.
Now, this next part I thought was interesting. They were talking about fine-tuning Solar for specific tasks, and they mentioned using these data sets with these really interesting names. Alpaca GPT-4,
Yeah.
OpenOrca. What are those all about?
So those are specialized data sets that are used for something called instruction tuning. Basically, it's like giving Solar a crash course in how to follow instructions. Like, imagine you have this brilliant student who aced all of their exams, but they've never actually applied their knowledge in the real world.
Okay, I get it.
Instruction tuning is like giving them that real-world experience.
So it's like an internship for a language model.
Exactly. And what's really cool here is that the researchers actually went a step further. They made their own specialized data sets for math. They called them Synth Math Instruct and Synth Math Alignment. Basically, they took these existing math problems, reworded them, and used that to train Solar's reasoning and problem-solving abilities.
Wow, so they're really putting Solar through its paces.
Yeah.
But they didn't stop there, did they? They also mentioned something called alignment tuning. What is that all about? Is Solar joining some exclusive AI club?
Not exactly. Alignment tuning is about making sure that Solar's answers are not only right, but also that they're aligned with, human values and preferences. It's one thing for a model to know the answer, but it's another thing entirely to be able to communicate that answer in a way that makes sense to us, in a way that's helpful and appropriate.
So it's like you can be a genius, but still need to know how to interact with people in the real world, right?
Exactly. And that's what's so interesting about Solar. It's not just about how much AI can do. It's about making sure all that power is actually useful for us humans.
Right. Like we were talking about earlier, they used that really innovative depth upscaling technique.
Yeah.
Building up instead of out, like upgrading a skyscraper.
Yeah, and that connects to this whole idea of making AI more aligned with human values, too.
Oh, how so?
Well, by building on these existing models that have already learned so much, they're giving Solar a head start in understanding how we humans communicate.
So it's like Solar has already done all the groundwork and can focus on the finer points of like being a good communicator.
Exactly.
That's amazing. So after this deep dive into Solar, where do we go from here? What does the future hold for AI?
That's the exciting part. This field is always changing. As researchers keep experimenting with these new architectures and training methods, who knows what incredible things AI will be able to do.
It's really an amazing time to be following all this.
It really is.
Well, this has been a fascinating deep dive, and Solar is definitely one to keep our eyes on. Thanks for breaking it all down for us.
Absolutely. It's been a pleasure. And for everyone listening, stay curious about AI because there's so much more to come.